All right, let's get into it. We're going to talk about brightness, but it's a little more complicated than you might think. We're tackling a really specific question. How do you measure light when it's not the same brightness in every direction? And to figure that out, we need to get to know a very special unit called the candela.
So if you've ever gone to buy a light bulb or maybe a projector, you've probably seen all these different words thrown at you. Lux, lumen, candela. And you might think, why? Why can't there just be one number for how bright something is? Well, it turns out there's a really good reason. Each of these units is a specific tool that answers a very different and very important question about light.
You know, to really untangle all this, we have to start with one big idea. We need to draw a line in the sand between two concepts. The light that's hitting a surface, you can think of that as the result, and the light that's actually coming from a source, the cause. Getting this distinction down is the first key to unlocking the whole thing.
Okay, so let's start with the one you're probably most familiar with, even if you don't know the name for it. When a lamp shines on your desk, that surface is lit up, right? Well, the measurement of how bright that surface is, that's called a luminance, and we measure it in lux. You could literally take a light meter and measure the number of lux on your desk right now.
So, if lux is so simple, why can't we just use it to measure the light bulb itself? Well, this right here shows you the problem. Lux is completely tied to distance. The farther you get from the light source, the lower the lux reading becomes. So it's great for measuring the effect of light in a room, but it's not so great for describing the source itself.
And here's the part that really catches people off guard. That drop-off in brightness, it happens fast, really fast. If you just double your distance from a light, the brightness doesn't get cut in half. No, it falls all the way down to just 1/4 of what it was. That's because the same amount of light is being spread over a much, much bigger area. It's a pretty dramatic effect.
Okay, so if lux depends on distance, we need a better way to talk about the source. And that's where luminous flux comes in, which we measure in lumens. Just think of lumens as the total raw firepower of a light source. It's all the light it kicks out, in every single direction, all added up. This is exactly why projector specs are always in lumens. It tells you the total light output no matter where you put the screen.
So let's just make this crystal clear. Lux measures the result, the brightness on a surface, and it changes with distance. Lumen measures the cause, the total light coming from the source, and that number stays the same. It's kind of like the lumen is how much water is in the cloud, and the lux is how much rain is hitting your specific square of sidewalk.
All right, so we're feeling pretty good. We've got lux for surfaces, lumens for the total source. Problem solved, right? Well, not quite. What happens when a light source is designed to not shine equally in all directions? And that brings us to our next big puzzle, the spotlight mystery.
I mean, think about a spotlight. Its whole purpose is to focus light into a beam. It's super bright in the middle and fades out at the edges. Now, a lumen rating tells us the total amount of light coming out of that spotlight, but it tells us absolutely nothing about how focused or wide that beam is. It can't describe that directionality at all.
And if you ever look at the technical diagram for a light like this, you'll see a totally new unit pop up. It might say something like 400 CD right in the center of the beam, and maybe 200 CD a little off to the side. So what in the world is CD? This little abbreviation is the exact clue we've been searching for.
That mysterious CD, well, it stands for candela, and it is the final piece we need to solve our brightness puzzle. Luminous intensity, measured in candela, is the tool we were missing. It doesn't measure the total light, and it doesn't measure the brightness on a surface. What it does is measure the amount of light being pushed in one specific direction. It is the perfect unit for describing something like a spotlight. And the name itself is actually a huge hint. Candela is literally the Latin word for candle. It's a concept that's been around for a long time, and it's rooted in this simple idea of the light from a single flame shining in a certain direction.
So how do you visualize this? Well, imagine the light source is at the center of a big sphere. A candela measurement is like taking a slice out of that sphere, like a cone of light, and asking, okay, how much light, how many lumens are packed into just this slice? It gives us that intensity for a specific direction.
Okay, so we've met all the main characters in our story, Lux, Lumen, and Candela. Now, let's put them all on the same stage and see how they work together.
And here it is. This is the big aha moment. This one picture puts it all together. The total amount of light leaving the spotlight, that's its luminous flux in lumens. The intensity of the beam in a specific direction, stronger in the middle, weaker on the sides, that's the luminous intensity in candela. And the bright spot it creates on the floor, the result, that's the illuminance in lux. See? They all work together to tell the full story.
So let's just lock this in one more time. Lux is for the brightness on a surface. Lumen is for the total light from a source. And candela is for the light in a specific direction. Each one has its own very important job.
So why does any of this matter? Well, if you are a creator of any kind, this is basically your vocabulary. If you're a photographer, candelas help you control shadows and create drama. If you're an architect, lux tells you if a room is lit properly. If you're an animator, you're literally building worlds with these concepts. This isn't just boring physics. It's the grammar of how to speak with light.
Okay, so we've cracked the code for a spotlight. We know how to describe the source and the light hitting a surface. But what about the brightness of a surface that's the source itself? You know, like your phone screen or a TV? What about that feeling of dazzle you get when you look at it? Well, that, my friends, is a whole other level, and it requires a whole other unit. But we're going to have to save that one for next time.